Hello viewers, I am Dr. Mala Das Sharma. Welcome you to my channel Chemphilic. Let's start episode number 54 of Teaching Chemistry through Riddle. Here is our riddle number 54. X is an organic compound, gives shooty flame when ignited. It has two functional groups which are in conjugation. X can wipe out the pink color of potassium permanganate solution. Its interaction with sodium bicarbonate solution causes the release of a global warming gas. X can be prepared by Perkin condensation reaction and Knovangel reaction. So this is our riddle number 54. Now let's see the question. The question is, what is X? Justify your answer. The answer is X is cinnamic acid. Now let's justify our answer. So cinnamic acid, this is the formula, that is C6H5CH double bond CH COOH. Now cinnamic acid is aromatic. That's why it gives the sooty flame. In cinnamic acid, there are two functional groups. One is carbon-carbon unsaturation. This is aliphatic unsaturation, this part, and carboxylic acid groups. And these two groups are in conjugation. X, that is cinnamic acid, can wipe out the pink color of potassium permanganate solution. For aliphatic unsaturated compounds, when they are treated with cold alkaline solution of potassium permanganate, then oxidation takes place and the overall reaction is, or the net reaction is, this addition of this 2OH group at the adjacent carbon atoms, that means at the double bonded carbon atoms. So this pi bonds breaks and these 2OH groups are added, whereby 1,2-diol or glycol is formed. And this is the test for aliphatic unsaturation known as Bayer's test. So therefore, when this in unsaturated compound, cold alkaline solution of potassium permanganate is added, this pink color is discharged. So this is cinnamic acid. It has carbon-carbon double bond in the structure, and the compounds containing aliphatic unsaturation is oxidized by cold alkaline potassium permanganate solution to form the glycols or 1,2-diols. The pink color of the potassium permanganate is discharged, and this is Bayer's test. Now, next clue was, its interaction with sodium bicarbonate solution causes the release of a global warming gas. Now, this is cinnamic acid, and when this cinnamic acid is treated with the solution of sodium bicarbonate, then carbon dioxide gas is evolved as effervescence. Why? Because we know that in cinnamic acid, this carboxylic acid group is there, and these carboxylic acids are stronger than the carbonic acid. Stronger acid can release the weaker acid from their salt. Sodium bicarbonate is the salt of this carbonic acid. So, when the sodium bicarbonate solution is added to this cinnamic acid, that means compounds containing this carboxylic acid group, then the stronger carboxylic acid releases this weaker carbonic acid from this salt, that is from the sodium bicarbonate solution. And this carbonic acid, you know that two OH groups are attached to the same carbon atom, so unstable. Immediately water is removed. So carbonic acid means water and the evolution of carbon dioxide. So carbon dioxide gas is evolved as effervescence. Now the question is, why this carboxylic acid is stronger than the carbonic acid? If you consider this anion of this carboxylic acid, that is carboxylate anion, here this is the resonance hybrid structure, And these two canonical forms, they are equivalent structures. When the resonating structures are equivalent, they are more stable. That means it gains the stability. Now, if we see the canonical forms of this carbonate anion, here you see this is also resonance hybrid structure, and there are three resonating structures, no doubt, but here this 2 negative charge is distributed or delocalized between 3 oxygen atoms. Therefore, this charge density or negative charge density is more, whereas here 1 negative charge is distributed between 2 oxygen atoms. So as here this negative charge density is more, so it is less stable. We know that the acid strength of any acid depends on the ease of release of H plus and the stability of the anion form. As this anion of carboxylic acid is more stable than the anion of carbonic acid, that is carbonate anion, so carboxylic acid can release the weak carbonic acid from the salt of carbonic acid. Now, cinnamic acid can be prepared by Perkin condensation and Knovangel reaction. How? Knovangel reaction, this is a condensation reaction where first nucleophilic addition takes place between these compounds containing active methylene group to the aldehyde and ketone in presence of the amine base catalyst, say pyridine or piperidine. And then dehydration occurs, that is addition followed by dehydration or removal of smaller molecule. That's why it is condensation reaction. Now let's see. So this is benzaldehyde and this is ethyl acetoacetate, CH3CO, CH2, COO, C2H5. This is ethyl acetoacetate. It contains the active methylene group, this part CH2. This part is active methylene group because this CH2 group is attached in both the sides with the electron withdrawing group. Now in the net reaction, what happens here? These two hydrogen and this oxygen of this CHO group of benzaldehyde, it is removed as water. Then you will get this one. And here you see, now this one undergoes acidic hydrolysis. In my previous video, I have discussed about the synthesis from ethyl acetoacetate, where I discussed the two types of hydrolysis of ethyl acetoacetate. One is acidic hydrolysis, one is ketonic hydrolysis. How the breaking takes place, everything I discussed. Link is given in the description box. You can go through it. So, during acidic hydrolysis, here the breaking takes place, and when this breaking takes place, what happened here? From this part, what will form? CH3, CH2OH. The OH added here, hydrogen added here. And from this part, OH is added to this carbon atom, hydrogen is added to this carbon atom. So, finally, what product you are getting? This product will be this one. That is the cinnamic acid. This part breaks down, this part breaks down. From this part, you will get the CH3CH2OH, that is ethyl alcohol. And from this part, you will get CH3C double bond OOH. And this hydrogen added up here. So, you will get this cinnamic acid, which is alpha beta unsaturated acid. Now, the cinnamic acid can be prepared by Perkin condensation reaction, which is the condensation reaction between aromatic aldehyde and an acid anhydride in presence of the salt of that acid. Say aromatic aldehyde, benzaldehyde, and acid anhydride, say acetic anhydride, that is anhydride of acetic acid, and the sodium salt of the acetic acid. See here. So, sodium salt of the acetic acid, sodium acetate, it dissociates at acetate ion and sodium ion. This acetate ion takes this H plus from this acetic anhydride and form this carbanion. Now, this carbanion attacks this carbon atom of this aldehyde group and whereby we'll get this product. Now, hydrolysis occurs, and after hydrolysis and during hydrolysis, this acetic acid is removed from here, CH3 C double bond OH, and then we get this product. Now, from this product, this dehydration occurs. That means water is removed by this OH group and the hydrogen atom from the adjacent carbon atom, and finally we will get the cinnamic acid. So, cinnamic acid, it is aromatic compound giving sooty flame. It has two functional group, carbon-carbon unsaturation and COOH or carboxylic acid groups, which are in conjugation, and it can release this carbonic acid from the salt of sodium bicarbonate solution, that means salt of weaker acid. And this cinnamic acid, it undergoes or it responds to Bayer's test for unsaturation, and moreover, the cinnamic acids can be prepared by Knovangel condensation and Perkin condensation reaction. This is all about our today's discussion. Thank you.